Today we welcome a very special guest. We have with us Larry Carpenter, who's our Data Guard product manager, as you very well know. Larry, you want to just give a brief introduction about yourself, a brief, history of what you have done over the years?
Sure, no problem, Anil. Hi, everybody. I've been working with Data Guard since its inception back in the late 90s. Originally as a mission critical engineer evangelist in Europe, and then here in the United States and all over the world. Became product manager, 7 to 10 years ago, and have helped and watched it grow over the years, and worked a lot with the RAC group and Anil and others in that organization. And it's been a fun trip, and we're working our way towards just bringing the best to the table.
Great. Perfect. So today's session, as some of you might notice, is a bit different in the sense we are not going to be covering a specific topic with slides in a typical format. Today we're going to be doing more of an interactive session. So if you have any questions, and on top of what you have already submitted me via the Dev Gym or the Oracle Office Hours or Ask Tom website, however you call it, we'll go over those questions. And again, like I keep saying, feel free to ask us questions either in the chat, or you can ask us, via the Dev Gym or Ask Tom format. So today is going to be a little bit different in the sense we're going to go over those questions, try to explain a bit about why things happen the way it is, and maybe we can, make it a very productive and fruitful discussion. So having said that, I guess it's a bit interesting that we start the Oracle RAC office hours with an introduction to Oracle RAC. So just to level set, I guess everybody here knows what real application clusters provide, what are the benefits of it. But essentially, there are two aspects of Oracle RAC. One is the database that everybody knows. Yes, it's the offering which allows you to mount instances on different nodes connected to a shared storage. Perfect. This is great. I call it active instances, which scales writes, reads, and hybrid workloads. Like might have a mix of read, write, and whatever you want to, different proportions of each. So Oracle Real Application Clusters is not by its own, enough in the sense of providing availability, because sometimes the availability is outside the database, or the availability or issues, or the the operating system might needing to provide more availability. In that sense, Oracle RAC has actually what we call a RAC family of solutions via this additional concepts. Like for example, we have the ASM, which essentially provides high availability for the storage. We have clusterware, which makes sure that your operating system and your nodes are not sick. Because sometimes, it's not the instance that's hung, it's just sometimes it's the physical hardware issue, or maybe sometimes the operating system is stuck. So one of the key things that we haven't talked much about is this RAC solutions. And individually, I think a lot of people are very aware of what this family of solutions include, like Oracle Clusterware. Everybody who is aware or familiar with RAC knows about Clusterware and ASM, and the application continuity, which provides failover for the clients. So in this session, we're going to kind of highlight a bit about both and how they all work together for providing you the best availability. So having said that, let's go on to Data Guard. Larry, you want to say a couple of things about Data Guard?
Sure. As you know, Data Guard complements RAC in the sense that we work very closely together. And the Data Guard standby, as we show here, obviously can be a RAC cluster as well, with all the same, family members involved at the standby site. And that's really a good best practice, because if you run production on a cluster with certain things behind it, you're going to need those things when you fail over. The benefit of Data Guard, though, is in the sense that it's separated from the original database. So we're giving you data protection at every level. We do all kinds of Oracle-aware data validation, which is something that products like mirroring just can't do, because they don't know what's in the block that's actually being passed or updated, and what's in the reader that's being sent across. The big thing too is strong fault isolation. We want to keep the standby separate from the production database. So where you're running your production over there on your cluster and everything's working fine, we don't want anything that could happen to the cluster itself or the database, the storage there, or anything to affect the standby so that you can get back up and running. And the important thing is that with a physical standby, it's full database replication. It's the exact copy of production. So how things perform on your production server, they're going to perform the same way as far as the database is concerned on the standby when you start to move your applications over to a, after a failover or a switchover. And the other important thing too is real-time HADR. We complement RAC with a high return on investment as well, whereas RAC provides you the capability of scaling across all those nodes and having client failover and load balancing. We can move some of that workload in terms of the read-only workload off to the standby and get even more scalability out of this environment. But the other important thing is that you always know it's working because it's a live, active database. Even if you're not using it in RAC Data Guard mode and doing your production offload for read queries and so forth, even in mounted state, you can look at it, you can see that it's running. And that's kind of how Data Guard folds into this environment. Next slide.
Sure.
And so if you look at it, I think Anil will agree with me on this one. RAC, ASM, Data Guard, we're kind of the foundation of the maximum availability architecture. I mean, this is where the data is being protected at this level. And of course, there's a whole family of things around this, and I'll turn that back over to Anil to sort of finish this off.
Sure. Thank you, Larry. So as we go into some of the details of this, a couple of things, let's make it clear. So RAC, what I like to highlight is, provides you from what we call as scalability benefits, obviously. And in this particular slide, in the aspect of this particular slide, we're going to talk about more of availability within a site. So for example, if you look at the slide that we have on the left-hand side what we call as the primary site. On the right-hand side, we have what we call the standby site. So if there's a node issue on the primary side, or if there is kind of some storage issues, we kind of try to handle it within that site. It's very important that we handle the issues locally as much as possible, because there are connected clients who are essentially going to be talking to these instances and doing their insert updates or doing their DSS queries or whatever they may be doing, that we do not want to interrupt them too much, because there is always this aspect that we've been always talking about is, hey, my database is available all the time. That's great, but what's the big deal if your clients cannot reach the database, right? So it's always important that you always think about the database not as on its own, but database along with the clients, to make sure that the clients can connect, they can talk to them, they're able to continue doing their insert update or whatever queries that they're doing without being affected by issues. In this context, so RAC, essentially takes care of, all the local node aspects, and it's, obviously, site level failures do occur. We may not like them, but they do occur, and with certain customers, we have seen that they actually occur a bit more, depending on the criticality of data. They want to be more prepared. So obviously, you definitely want to have your data protected, because you don't want a site level failure to be, causing you loss of data. So definitely want to set up a standby. And in the standby side, we're going to send all the changes that are generated from the primary, as Larry said. Now, Larry, one of the questions that came up, and actually I think you touched upon it a bit, but I'd like to perhaps get a bit more details on this. So one of the questions that I got that was sent to me earlier is, I got my storage solution replicating my data. So why should I actually go with Data Guard? So could you please explain that, why Data Guard is a better solution than just storage replication?
Oh, absolutely. I mean, apart from just sheer load, if you look at a mirroring solution versus Data Guard, a mirroring solution has to send every single bit of every single I/O on every single file of your production database across to the mirrored copy. And in fact, it sends the redo twice. Once when the log writer writes the redo to the online read log file of the primary, because that's mirrored, and the second time when it's archived to an archive log, because that file is also mirrored. Data Guard, from a sheer volume point of view, is sending just the redo. We're sending nothing else. There's no other communication. There's no other connection. And that's the other problem. Because every file is being mirrored, there is no way of detecting until you actually need that mirrored copy if there's any problems in there. For example, a block corruption might happen on the production database. That corruption will be mirrored quite happily in many cases over to the standby copy, i.e. the mirrored copy, and you won't know it's there. Data Guard, apart from the fact it's completely separate at the storage level and the database level, everything is completely isolated as one of our prime directives. We're actually validating all that data that comes in. So as the redo comes in from the primary, we can look at that redo, know exactly what it should look like, make sure that it is okay. And then when we start applying it to the blocks of the standby, we can also look at it and say, this doesn't match, you've had a lost write, or hey, there's a corruption here, and that Data Guard can actually repair the standby automatically with a good block from the primary. So it's a completely different kettle of fish, and it's one of those funny things that over the years, when we've talked to customers about Data Guard, it's not just Data Guard for the Oracle database, it's whatever database you use, the database's own replication technology for standbys, i.e. HADR for DB2 or SQL mirroring or always-on clusters now for SQL Server. All of those tools for that specific database do some level of this isolation and validation. It's just that Data Guard does it for the Oracle database.
Perfect. I think that was a good point that you brought up. There are two critical phases, as you explained. One is that we would not write any corrupted data blindly on the standby side, even if it is coming from the primary site. We will ensure, because we know the format of the data blocks, we know the format of the redo. So if there is anything, any problem, we would actually just not write it. We'll make sure we will get the right data to be written. This is really interesting. I also like the second point where if on the standby you find something wrong, you would actually go to the primary, all without user intervention. Is that right?
That's correct. And we actually, with Active Data Guard, do it in both directions. If you hit a corrupted block on the primary, we can fix it automatically from the standby with a good block from the standby, recover it to the correct point, and return the data the user requested without any error messages and without any intervention by the database administrator.
Perfect, perfect. That is so good. Now, one question I had, which kind of I should have started with, but it came in the order and I just put them in my notes in the same order that the people asked. So what is the difference between Data Guard and Active Data Guard? So that's one thing that they've been asking.
Yeah, that's a good point. And it is, I do admit that it sometimes is a bit confusing because we're not really clear on is there a difference. In reality, Data Guard is Data Guard. And it's part of your Enterprise Edition. And when you install the Oracle Home on your primary and on your standby servers, you actually have all of the code and all of the technology of Data Guard and Active Data Guard. The only difference really is that to use certain features of Data Guard requires the Active Data Guard license. So for example, when we introduced Active Data Guard in 11.1 or 11G release 1, as we say, the only thing we had was the ability to open the standby read-only and restart the apply. Now, just a point of interest, you've been able to open a physical standby database read-only after stopping the apply engine since 8i. But you couldn't have it open read-only and have the apply running. So that still holds true today. If I went to my standby, stopped the apply, and opened it read-only, and looked at the database, I'm looking at stale data, but I'm not actually using Active Data Guard because the data is not being maintained while I'm looking at it. And then to get back to my apply state, I'd have to shut the standby down, restart it in mount mode, and then restart the apply. With Active Data Guard, I can go over to the standby and stop the apply, open it read-only, and restart the apply. And now I'm reading new, fresh data, but with complete consistency, read consistency, and ACID properties that you would have if you were reading the production database. In other words, you're not going to see dirty data. And that was the basis of Active Data Guard in 11G Release 1. And over the years, things have come along that because of the things we can do with the standby database open and read-only mode, we can add things in. So for example, 11.2 brought in the automatic block repair we were just discussing. And then 12.2 or 12C release 2 enhanced that even more by repairing even more blocks that could possibly go corrupt. And then other things came along, such as being able to use global temporary tables on an RAC Data Guard standby. Obviously, if it's not open read only, you're not doing any DML to those global temporary tables. But once you've got it open, all of a sudden all that technology is available to you. And then like far sync instances, being able to do zero data loss over WAN distances. In other words, having your production database in Chicago and your standby in Dallas, you wouldn't ship synchronous to get a zero data loss failover. But because if you've licensed Active Data Guard, you can use the far sync technology and ship reduce synchronously to a local far sync and let it do it asynchronously to Dallas. And then when you say, hey, I've lost Chicago, let me fail over to Dallas, as long as we can get to that far sync instance, thousands of miles away, we can do a zero data loss failover. So it's not really that it's something that you have to install separately or it's a different kit that you get. It's all the same stuff. It's merely the license that gives you the right to use the technology that is part of Active Data Guard.
Good. That's good. So one of the things that you just mentioned, I think maybe we may want to spend a bit more explaining about some details on that, is this protection modes, especially you talked about the in the context of FarSync. Do you want to just give a small summary? Because I'm not sure if everybody who's joined us would be aware of what a FarSync and what the concept of protection modes are when you talk about
That's a good point, because people do have some misunderstandings about the protection modes as well. To give you the history of it, back in Oracle 9i Release 2, we introduced 3 protection levels. Prior to that, we really kind of had protected, unprotected. And what we were attempting to do is to put rules into your data guard configuration that where specific things would happen in a different protection mode so that we could maintain the level of protection that you, the user, required. So for example, the default is maximum performance now. Basically what that says is, I'm going to have standbys. I may not have any standbys, you still be in max performance, but let's, for the sake of argument, I've got a standby. I'm going to send to it asynchronously because I don't want any impact performance-wise to my production workload, my production application, my production system. So asynchronous transport has evolved over the years to now, as of 11G, our streaming protocol makes it entirely possible to ship long distances without any impact to the production database. And our data loss semantics, if you did have to fail over to that asynchronous max performance standby, have gotten better and better and better, especially with new networks, faster networks, more, consistent bandwidth, consistent RTT or round trip. And it's made it easier in max performance. But basically, it says that when you have a single standby and you're running in max performance and asynchronous, you will lose some data at failover. And it's hard to tell you exactly how much, and we definitely can't tell you what you lost. Nobody can, because nobody knows what's actually in those transactions, in those data blocks. We just know how much redo or how many, in a mirroring case, how many seconds worth of blocks didn't get replicated. Max availability was our first kick up to zero data loss, saying, okay, I'm going to ship synchronously, so the standby shouldn't be too far away because I don't want too much impact on my production database. But when I fail over, as long as the network and the standby stayed up and the primary site or whatever went down in a heap, I can go to that standby and say fail over, and I know I've got zero data loss. But in the event that the network goes down between the primary standby or the standby goes down, basically the primary says, okay, in max availability mode, I'm allowed to diverge, meaning I can still generate redo and generate transactions, and the standby will fall behind and we'll catch it up when it gets reconnected. And once reconnected and resynchronized, we're back to zero data loss mode. So there might be a slight hiccup, but no real damage to the production database if we lose our only synchronous standby. Now that's where FarSync enters in, because you can either ship directly to a local standby database somewhere within that 0 to 4 or 5 milliseconds of network latency, or you can put the FarSync there, ship to it in synchronous mode, and let it ship further on, so you get that zero data loss farther away. Now, the top level is called maximum protection, and maximum protection is what we call the guaranteed zero data loss. In other words, we will not allow a transaction to commit on the production database that has not been received by at least one synchronous standby. That's why at that mode, you have to be shipping directly to the standby. We do not allow far syncs in that mode. We do not allow this new mode called fast sync, which takes some IO out of it. And in that case, if we lose our last synchronous standby, everybody's frozen at the primary database. Everybody who's saying commit is just held. We don't commit. And we try to reconnect for a number of retries, and that sometimes comes out to between 5 and 10 minutes of a hang. But if we cannot get reconnected, we will abort the primary database, because what you've told us there is do not allow anything to be committed to my application that is not salvageable at a standby. In max availability, we allow that divergence. In max protection, we do not. Does that help?
That's very clear. Thank you. Thank you, Larry. So this came up actually in one of the internal mailing lists that we have. So I'll kind of a little bit go over a bit about it. So this person, I'll call this gentleman, had a question about, hey, what happens if there is, one of the instance on the primary side crashes for any reason, or what happens when the instance crashes on the standby side? So let me just take a step back and explain that regardless of each site being a primary site or standby site, when you're running RAC, the Oracle clusterware, first of all, is responsible for what we call as the clusterware membership. So every node that comes in has to say, yes, I will abide by the clusterware rules, otherwise I'll be thrown out. And therefore, these rules are checked very, very strictly. The database has what we call its own checks and what we call its own rules. So on the primary side, let's say one of the instance crashes. That's perfectly fine in the context of Data Guard because we would be continuing to send those changes from the other instances. That should be fine. And let me also take a moment here to explain that it is perfectly fine to have a primary site with 2 or 3 or 4 nodes, and you would have a standby site with just one instance or even a single instance. You don't even need RAC. You don't need to make it exact. Obviously, if you are planning a production or critical database where you want to have the same benefits, the same performance, the same things or workloads that you were running on primary to be running on your standby site, you definitely want to keep it as similar as possible. Like if you have 3 on the primary side, 3 nodes or 3 instances, you want to have very close or at least 3, right? Again, the question that has come up was there any chance that if the node 2 or instance 2 of the primary set crashes, would be hanging or something? No, so we actually keep sending those information from the other, one of the other RFS process on the primary side would continue to send it. So it would be good. The moment the instance crashes, the clusterware would attempt to restart that instance. And if it's able to successfully restart, it will join in. And other than some alert log entries notifying you that, hey, that instance went down, pretty much the data would be synced up very, very, without users even knowing that no instance went down. Now, the other thing that I want to also explain, the same way it works on the standby side. So if the standby site, you have in the image that you have actually what we call 3 in an instance on the standby side. And in these 3 instances, you have what we call as the media recovery processor running, and they're applying all the changes, keeping the standby up in sync. If one of those crashes, no problem. The other guys will continue to do its work. And again, there's all dependent on load, the amount of load that the other 2 nodes can sustain. But pretty much you would be in sync, and we would respect the protection mode that you have set when you initially define the standby configuration. Also want to add, what happens to clients? So if you look at the clients that is connected to the primary site, and let's say this instance goes down, obviously we have what we call as, people remember it as TAF, Transparent Application Failover, and in the later releases, we got application continuity. So this entity will ensure that the clients can connect to the other RAC instance on the primary site. Now let's take this a bit further. What happens if this whole guy goes down? As the primary site is completely down. Using the entries that we have defined, the VIP would, the scan entries, the clients who are connecting to the primary site would be able to connect here. But if this guy goes away, the same chain as name entries are already pre-populated with the standby site. So when there is what we call as a switchover, which is a planned, or if it's a failover, the clients will be able to connect to the new or to the standby site. And again, depending on if there is a failover, which means you're switching over this standby site to a new primary, the connections move over without much impact. Obviously, when I say without much impact, there may be some impact because it depends on the nature of the failure. The nature of the failure is very, very abrupt. Yes, things fail over very quickly. But if the things are going on in a fashion where the nodes are hanging or the site is just getting into a crippling halt, then obviously it'll take a little bit more time. But the fact remains that the clients have the intelligence built into them that they first go to the different nodes of the primary site, and if everybody of them is down, we would move over to the standby site. Now, a question for Larry that has come up is, how does the broker integrate with all this? Does broker talk to the clusterware, or does it makes its own decision? Larry, you want to explain a bit about that?
Well, actually, that's a very good point, and we recommend that everybody who uses Data Guard uses the Data Guard broker. It's part and parcel. There's nothing extra to install. You just literally set some parameters, turn the broker on, and then do a few command line commands. Create configuration, add your standby databases, and then you edit properties, and bang, the broker takes care of everything for you. And one of the main things that the broker brings to the table is that during that failover, when the services are being migrated, there's nothing to start the service automatically on the new standby. The broker will do that if you're using clusterware, and that's everything from Oracle Restart to RAC 1 node to full RAC real application cluster. But in addition to that, the broker is the only thing that actually fires the notifications for your fan events, so that clients who are attached to the old failed primary and haven't been disconnected get knocked out of that hang and told to start reconnecting, and they'll get connected to the service now, which is now running on the new primary, which was the standby. And if you don't use the broker, you end up having to implement things yourself to do triggers, to do callouts. It just becomes very, very messy, and it doesn't fold into our client failover strategy that Anil was just talking about, whereby we're going to make most of that automatic, so that you don't even your application doesn't have to do anything. You talk to our drivers are the ones that are going to control all that. The app will just see a slight pause and say, oh, okay, we're continuing. And so it's very important that you use the Data Guard broker to manage your Data Guard configuration. Apart from all the other things it brings, that's one of the biggest things that it does now, is that notification to those clients that get those services started and get those clients failed over.
Perfect. That's a good point. So there's a question that I got. This is about, this is a very interesting question, Larry. This is about, actually, I think I better answer it, but I'll just put it out for you. You can start and then I'll answer it. The question is, there's a lot of questions about stretch RAC clusters. Can you explain what to use when and what they're briefly? So Larry, you want to go for it, or should I start?
Well, why don't you explain what stretch RAC really is and so forth, and then I'll add on how Data Guard complements and extends, if you will, an extended RAC.
Perfect. Okay. So for those who don't know, typically RAC nodes are very close to each other. When I say very close, they are mostly next to each other. There is this concept, though, that you can separate these nodes out across larger distances. This is very common in, I've seen Europe doing this a lot. Some customers in Europe, customers in Australia, South America. Apparently, they can provide, or they plan to have their site node 1 and node 2, or regardless, this node separated by about 50 kilometers sometimes, and that's very looks like they want to do that. Now, again, there is nothing wrong with that. It's just that the speed of light is fixed, right? So as you spread these nodes, the latency increases, and sometimes these things needs to be written to disk, and we need to have the disks in both location. We need to have a quorum site. So all those are something that stretch clusters require. It's not a problem that the stretch clusters introduce or something. It's just the fact that the more the latency, the more the application will see some of these performance issues. Now, granted, this has been around for a long time, like 20 years, and over the years, hardware has got good and networks have got even better, especially if you use dense fibers and things like that. Customers have been using stretch clusters for a while, and last I talked to a customer about a couple of months ago in South America. They're very happy with this. In fact, some customers in South America, some bank has actually standardized on this. They have this nodes, I think 3 nodes on one side, 3 nodes on the other side. They're always deploy stretch clusters. Their idea is to use what we call active-active. So they have a services on certain nodes which are on one side, and then they would have some other services which would go to the other side. And usually they are these reads that they can spread to the other side. So that's what stretch clusters are. And there always comes this thing, hey, what is is Data Guard better, or this is better? And actually, let's just put an end to that. Our recommended strategy or recommendation, if you want, what we call the maximum availability architecture, is to use what we call RAC and standby for site level protection. So this is something that's been there. We have tested this. Maximum availability architecture is just not RAC and Data Guard. It's actually a bunch of these things. There's a whole team whose job is to just test these various failovers, failures, pull out disks, pull out networks, make sure things work. So what we call maximum availability architecture, which includes RAC and Data Guard, also includes a lot of the other parameters. Having said that, what those customers who are currently using stretch clusters, they're fine. It's not that we are saying that's they are it is, as long as it does take care of their requirements, it's fine. But Data Guard and maximum availability architecture is what we call the premier protection that you get from all kinds of data failures. Larry, you want to add something more?
Well, yeah, I'd just like to add to that. I mean, Stretch RAC, like you said, has been around for a long time. I spent a number of years in Germany with Oracle, and there were Stretch RAC clusters everywhere because they didn't need their data outside the country. They couldn't have it outside the country in those days. And so it worked quite well, given all the caveats you were talking about, and things have gotten better. The thing to remember, though, is that while a Stretch RAC gives you some extended HA in the sense that if you lose one data center, the other one maybe 50 kilometers, 60 kilometers away is somewhat isolated. But there is still the concept that this is a RAC cluster, this is a single database, and there are things that can happen to take out the cluster or the database itself. This stuff happens. So it's not really DR. And that's why we've always recommended that even with the stretch cluster, you'd want to still have a standby somewhere, and preferably in a third site somewhere else that can't be affected by failures of the other two. And it's just that complement I was talking about earlier, where the two paired together just provides you with the most data protection possible, because things will happen. Stuff does happen, whether we like it or not. These kind of things, these kind of failures can happen, and that's why we always recommend. And in fact, I've had a couple of customers said, well, I only have the 2 data centers. Where do I put the standby? And I said, well, in that case, you may want to put a standby on either side, because you don't know which side is going to be running, at what time. If something happens to the storage or whatever of one side of your stretch rack, but not the data center, the other side is going to continue on, but now your standby is sitting only in the same room, perhaps, as your primary. So maybe you have a standby back in the other one. So there's lots of things to think about, how to make this the true MA environment so that you are protected from all these various failures.
Right.
Now,
go ahead.
I've got a couple in chat here I'd like to address. I'm going to talk to Georgie. He's asking about working on designing HA for our apps, but not sure which solution. You know, they have 2 data centers in a region, and he can use GDS, Global Data Services, and balance the traffic between the 2 data centers. Well, it's an interesting. You know, it goes on to talk about primary and standby and active data guard. You know, what tools we use. The point about Global Data Services is that it is sitting above. It's basically like the scan listener was a layer of abstraction from a RAC when it was introduced, so you don't have to be messing with VIPs and all that. GDS is a layer of abstraction above that to your entire environment. So obviously, if you have a RAC cluster with 6 nodes, whatever, you don't really need GDS. But if you've got a RAC cluster with 6 nodes, you've got a RAC standby with 6 nodes, GDS comes in handy because in the event of a failover, it can actually start the services in the right place. But where it really starts to bring in the benefit to the application is when you have read-write and read-only activities going on, and where you have maybe multiple active data guard standby. In other words, for the right person in this environment, there's only one source of truth, and GDS will make sure that that service for those read-write applications is always at the right place, always at the primary. Whereas if you have multiple read-only sources, so you might have multiple targets that could give you the source of truth for read-only transactions, Global Data Services will make sure that those services are started. And perhaps you might say, well, you know, people who are attached to one data guard standby using a particular service because I want to load balance, or I want to separate them from the other standby, GDS can say, okay, that guy's gone. Let me start that service up on the other standby and move those people over there. Or perhaps let me move them back to the primary because it's closer. So all that intelligence is built into the Global Data Services environment. And this is why it's also the foundation for our sharding effort, which is not for this episode, but is an interesting thing. So, you know, if you want to use that load balancing for reads and for your writes, that's how you do it. Now, the interesting about, you also asked, Georgie, about how about Golden Gate going in active mode, and I'm writing and reading on both sides. That's fine. And again, that's another way Global Data Services can help, because there is no concept of a failover in that environment. So Global Data Services can maintain the services for you for those particular multiple sources of truth, if you will. And it could load balance users between them and that kind of stuff. But the thing to remember is, one, for Golden Gate active, bidirectional replication, you're going to have to, you know, even though we're taking a lot more work to automate conflict detection and resolution, your application still has to be aware that this is going on underneath. And on top of that, because both sides are independent of each other, you still would want standbys off of both of those Golden Gate sources, because something might happen where we can't do zero data loss to another Golden Gate target, but we can to a standby, and you could just pick up and keep right on going. So those are all the things you kind of have to take into account in that environment. And when you talk about, you know, operating system and database patching in a rolling fashion and so forth, you can do them with all of these things. I mean, RAC has rolling capabilities for upgrades and patches. Data Guard has standby first patching if you don't want to do it on your production database. We have transient logical for RDMS upgrades. Data Guard doesn't care about the operating system, so you could set the standby site down, upgrade the operating system, bring it back up. Data Guard will synchronize it, and you're running from Red Hat 5 to Red Hat 6. That's sort of fine. We don't really care, right? So you can do all those things completely independent of each other with a primary and a standby database. Golden Gate does also offer some of those capabilities, but in a slightly different manner. So it becomes a judgment call as what you might want to do. And then the last thing is, or maybe invest EBR. Edition-based redefinition is for application upgrades. And you're not going to do those with a RAC, and you're not going to do those just with a RAC, I should say, and not going to do those just with Data Guard, because you can't change the schemas. So you can, though, with EBR, do that on the production database, and your Data Guard standby just follows along. Or if you want to separate them out, yeah, you could use a Golden Gate target where you did the application upgrade over there and did some sort of very, very well-managed, you know, active-passive kind of Golden Gate replication, and then move your applications. But again, those are all things you have to take into account. Now, if I didn't catch everything already, please feel free to add another question onto the chat. Fang says, for Data Guard, what is the best way to monitor standby performance? 18C did add actually 12.2, I'm sorry, added the ability to run AWR on your standbys now. They have a whole new architecture where you have a AWR repository and you can register all your various databases, be they production or standby databases, and then you can run snapshots either manually or automatically, and all the information is rolled into the repository where you can evaluate it. And you can use that to also do SQL tuning, so you can run tuning exercises on your standby, so all the heavy lifting is done on the standby database, where the few things that have to be made persistent into the database are sent back to production and executed and then brought back to the standby and the redo. So now you have full AWR and SQL tuning pack to be able to monitor and tune your queries and also monitor your redo apply and figure out what you need to tune there as well. And that's all part of 12.2 onwards.
Larry, one question here. So I think maybe you want to clarify this, but I thought just for the person who asked that question, generally, there is no need to do any kind of performance tuning for the apply process or all that. The monitoring the performance is in the context of some queries running there or some things like that. Right?
Well, no, in actual fact, there are times that you need to tune the apply depending on your particular configuration and so forth. And we do have redo apply best practices that tell you how to get the most speed and the most power out of your redo apply. And AWR gives you that information as well. You're right, though, you don't run SQL tuning to tune the apply, absolutely. You would look at AWR, you'd figure out where the bottlenecks were, and you'd fix those bottlenecks, and that's what's in our best practices.
Perfect, perfect.
Okay, now, here's another question that, Fang, I'm sorry if I'm pronouncing your name wrong. For logical standby, we have a process on the primary to convert the redo string back to DML that can be applied to the logical standbys. Well, first off, let me address that. There is nothing, when you have a logical standby, there is nothing being done on the primary database other than shipping the redo. All the work is done on the logical standby. Unlike Golden Gate, where if you use the traditional Golden Gate, it is capturing and doing all that conversion process on the primary database, and I'll address that in a second. For logical standby, we're merely shipping redo, asynchronously or synchronously if you want, to a logical standby, and then that conversion work is being done at the logical standby database. Now, it says, is there a way to offload the conversion process running on a FARSync instance? Again, there's nothing to offload as far as conversion because it's just redo transport. Could I have a logical standby as a terminal standby off of FARSync? Sure, because FARSyncs are just forwarding the redo. But again, all the work is being done at the logical standby. So again, if I haven't answered that, feel free to add a new one. And this next one is for you, Anil, because for RAC, what is the best practice for remote listener on top of scan in a RAC environment? Say we use a PDB consolidation, and I have 2 RAC clusters on each, which are holding 4,000 4K PDBs. I want to have a central pool of listeners, i.e. same host, different service. Will we be better with remote listener or connection manager? Is there a way to have a group of scan connect to a different RAC, say in our new domain cluster?
So that's a very lot of questions actually. Let me address that one by one. So in RAC, when you set up scan, we would automatically set the remote listener settings. The agent that manages the database would do that. So in that sense, you don't have to do anything to the remote listener itself or those setting itself. But this is a very common thing, especially in today's world where we're seeing a lot of consolidation, and I'm glad that it's actually done via PDB. So when you have 2 RAC clusters and holding any number of PDBs, there are a bunch of RAC features that actually help you to manage this. For example, when you're running your PDBs on a RAC cluster, you're actually, by default, providing them availability. So that's one thing. The second thing is two-node rack, maybe a different one. But let's say we have 4-node rack cluster or more nodes, then you could actually have a subset of these nodes have some PDBs. For example, let's say in a 4-node cluster, out of the 4,000 PDBs, you would actually have, let's say, 2,000 on two nodes and 2,000 on the other nodes. This again, the question came from another customer too about, do we want to use a central pool of listeners? See, it's really the way how the architecture is implemented. The listener, when your connection comes in, this scan listener does not actually do a whole lot of work other than redirecting the client to the node which hosts that service. And after that, the listener will just respawn a connection and hand it off to the client, and then the client talks to that, and it's done. So what my point is there is not a whole lot of work done. Now, there was a customer case where they said we absolutely need to abstract this, where out of the 4,000 PDBs, as in the example here, 2,000 PDBs definitely do not want to be on the same network even. Again, like I keep saying, the separating the listener is the easy one. Separating it across different interfaces is the hard one, because it's 4,000 PDBs. You do not want to have 4,000 interfaces. When I say network interfaces, I mean. So it's really dependent on what is the specific case here. But if you want to keep it simple, just have the RAC cluster and spread over the PDBs as much as you want across them, and use the web, and you should be good. You just start the service that you want. That way you have that there. You do not specifically have to do all that, but you could do all that. You could have different scan connecting to different PDBs. All those are possible, but I think it would be too much. About how does this affect domain cluster? Well, the domain cluster does not change any of this recommendation, because remember, a domain cluster, the facility that it provides is services to the member cluster. And in this case, the member clusters are running the PDBs. And I'm assuming that all the 4K you want it in 2 member clusters. So I'm just trying to make sure that in a small amount of time, that explain that you do not have to. You could go with what we call the simple route. But again, I have had customers who tell me, no, Anil, I definitely want this kind of isolation, and we can go that route. Hope that answers that question.
If not, they can bring it back. I've got a couple follow-ups from Fang. He asked, for the lots of standby, what does the package I compiled on the primary do? All that's doing is it's looking at all the metadata of your production database, and it's building what we call the dictionary for the logical standby, so that the logical standby knows exactly what the production database looks like. So it's building it, and when it's done, it's just sending the redo of that dictionary. And on the standby side, the logical standby is grabbing that and building the dictionary over there. It's not actually doing any DML conversion. It's not doing any processing of the redo in that sense. It's merely building the dictionary. And the last one, you asked about standby AWR. You couldn't seem to work it. And unfortunately, I don't have an answer off the top of my head. However, everything that I know about this is in the link I'm going to put on chat right now. That's the link to the Database Performance Tuning Guide, where it talks about running AWR on your standby database. So obviously, that's part of the whole AWR setup, that you'll need to make sure that you did things right. But other than that, we really can't answer that question if you had problems with it in the past. We'll have to either open an SR if the documentation doesn't help.
One question, I think we have about 5-6 minutes. I don't want to run to almost the end of the hour, but one question, Larry, that has come up in the pre-submit questions that we have on Ask Tom DevGym is been questions about fast start failover. Maybe you can take a couple of minutes to explain that before we get into more question and answers, please.
Yes, I'm happy to do that because it's interesting. Fast start failover is part and parcel of the broker. You do need to be using Data Guard broker to manage your Data Guard configuration to use it. And it's been around since 10G release 2. In 10G release 2, it only worked with a synchronous max availability target. Starting in 11G, we allowed asynchronous max performance targets as well, and you tell us how much you can, data you might be willing to lose. In a nutshell, the way it works is that you set up some prerequisites on your primary and your standby database, and then you start what we call the observer, and then you enable it. Now, the observer, some people think the observer is the broker. It's not. It's really just part of DGM drill. It's a client interface that you run on another system somewhere. Its whole purpose in life is to basically make quorum to make decisions. The problem with a prime and a standby pair is that one of them can't make a decision without the other one, and that doesn't work when one of them is dead. In other words, the primary goes down. How does the standby know to fail over? The observer provides that quorum, and the observer is running on some small system somewhere, and there's version interaction. We have notes on that. But all it's doing to begin with is just connecting to your production database and saying, hi, are you there? And as long as the primary database says, yeah, I'm still here, it's nothing different than going to SQL Plus and making connection to the database. It's basically just watching the primary database. In the event that the primary database decides not to answer because something has happened, then it will start to count down while continually trying to get an answer. And you tell us how long you want it to count down. And if that threshold expires, it turns around and does a failover of the target standby, provided that all the data loss semantics are met, i.e., if it's synchronous max availability, is the standby capable of doing a zero data loss failover? If it's a max performance and asynchronous standby target, is the standby not going to lose any more than the data that you said, the lag limit as we call it, that you said was permissible? And there's a lot of communications going on in back. There's a lot of different properties built into this, but that's it in a nutshell, where basically what happens is I can't talk to the primary, it's gone, I'm going to go to the standby and say failover. Now, it's possible that the standby can say, hey, I can see the primary, so should we really fail over? And in the past, we wouldn't do that. Well, we added a property for that. You can tell us, hey, if the observer can't see the primary, even though the standby can't, my applications probably can't see the primary anyway, so fail over. We call it the override property, if you will, and we'll do the failover anyway. So we've got lots of things like that built into Fast Start Failover. And its whole purpose in life is to take the person out of the decision-making process for a failover. And we've seen people come back, and Amazon's been using this since 10G release 2. And from day one, they said, you know, it used to take us 60 minutes to do a failover any one of our 350 databases. And they got more now. They put Fast Start Failover in there, and it was down to 2 minutes. They were up and running again, and there was no human interaction. So you don't get the call at 3 o'clock in the morning. It just happens. The nice thing about Fast Start Failover 2 is that in some high percentage of time, 98% of the time maybe, there's actually nothing wrong with the production database. It's just the system went down, or somebody pulled the plug, or the power went out. When it comes back up, Fast Start Failover is the only thing that can prevent a split brain. If you don't have Fast Start Failover enabled, and your old production database is able to come up, it could actually start its own services and start accepting transactions, which is called a split brain, and that's not what you want. With Fast Start Failover enabled, we prevent that. The broker actually stops it. It says, hey, I need to talk to somebody before I can open, and if he can't talk to anybody, he doesn't open, period. He just stays in the mount mode. But if a failover has happened, then the observer says, no, we failed over, and it automatically makes him a standby. It flashes him back a little bit, converts him into a standby, bounces him, starts the apply, and then Data Guard resynchronizes. And now, once synchronized, Fast Start Failover is ready to go in the opposite direction, which is why people like Amazon and other places that are using this now don't worry about moving back to production, because they've set it up so their clients have failed over, they're running over there. Why take another outage to move back? Just leave it, enabled in the opposite direction. And that's really what its purpose is. And one of the questions that Georgie just brought up is, so where do I place the observer in case of 2 data centers? Well, that's a very good point, because placing the observer is the most important thing. You really, for best practices, you need a 3rd data center, you need separate networks, because you don't want something that happens to one side or the other to take out the observer and the standby at the same time, for example. So let me give you an example. You asked Georgie, should I place it on the primary side? Let's assume, first off, never put the observer on the same system as either any of the databases, but if you put it into primary site and the standby goes away, the primary will ask the observer, hey, I lost my standby, can we become unsynchronized? And the observer say, yeah, I can't see him either. Let's just move to unsynchronized, keep on going. Divergence is okay because we're in max availability or max performance. When it comes back, the standby gets rehooked up, the observer watches everything, says, okay, we're synchronized again, we're ready to go. In the event that the production database goes down, say the whole cluster goes down, or something happens to the database storage that caused it to crash, the observer is in the same site, it'll watch that, can't connect, it can see the standby, and it'll do a failover, right? That's fine. But if the entire production site goes away, the standby's got nobody to tell him quorum, hey, you should fail over, so no failover will actually happen. The other thing that's a problem is if you put it on the standby site, which is going to be George's next question, if we lose that primary site, yeah, we'll fail over. The problem is, if it's on the standby site, a simple network connection failure between the production and standby DR site, data center, will cause the observer and the standby, the target standby, to go away at the same time. At that point, now the primary has nobody to ask what happened. Am I just unobserved or am I unsynchronized? And basically, the primary database will abort itself because we cannot risk that a failover had happened, which it probably did if the standby site didn't go down, and have a split brain. So that's why it really is important to put it on the third site. And several customers I've talked to in the last few months, because activity in questions about fast start failover are just increasing, exponentially. It's crazy. Are putting their observers in the cloud, and because it's a very lightweight connection, it does just small, packets back and forth. It's not sending large amounts of data. Latency isn't quite as impactful. There will be some, you have to think about, if it's a lot of latency to the cloud image you've got, you may want to increase your threshold a little bit. But basically, that's what they're using for their third site, and that is going to be the best practice.
Cool. I think, Larry, thanks for that wonderful explanation. I think we are pretty much out of the hour. So unless there is a quick question, I think we should start wrapping up. So first of all, I'll go first in this. Thank you for all of you guys who attended and asking the questions. I want to especially thank Larry for coming here and explaining all these concepts in so much detail. I really appreciate it, Larry.
No problem. It's been an absolute pleasure to be here and answer these questions, because a lot of times these questions are out there, but nobody has a way to get them to us. And this is a perfect venue to do that. I really appreciate you inviting me along.